evaluate this line integral where this f is given by this vector, and we always denote by p, q, r, but there is no third component, and c is the arc of the hyperbola, this c, from 1 1 to 5 1 over 5. So initial point, terminal point. So let's check if this force is conservative. First we want to check the domain of this function. Look at this. This is nice. I mean, there are no fractions, no square roots. That means the domain of this function, this force f, is all the points in the plane, all the points in R2. Okay, so the domain is simply connected. No problem with that. Next we find the parcel of p with respect to y and parcel of q with respect to x. If they are same, then f is conservative. Parcel of p with respect to y, this is 0 to x constant, derivative of y square 2y, 2x times 2y, 4xy. Parcel of q with respect to x, so that's 4xy. Oh, they are same. So this is conservative. That means we can find, that means then we can find a function of two variables, because our f has two components, function of two variables, such that grad f is equal to this f, and this is called potential function. And to find this f, what happens is the partial derivative of this potential function with respect to x is p. First part, 1 plus 2xy squared, let's say equation 1. I'm going to find this potential function f, okay? And by the property of this grad f, so partial with respect to x is first component, partial with respect to y is second component, 2x squared y. Some of you might be able to guess this function f. I mean, that's all right. Now let's integrate 1 with respect to x, or 2 with respect to y, same thing. So antiderivative is just f as a function of xy is equal to antiderivative with respect to x, just x, plus y squared behaves like constant. Antiderivative of 2x is x squared, so x squared y squared plus a constant, but that constant could be a function of y, so we write h of y, where h of y is a constant of integration. Next we want to find, we want to compare with 2. Look at equation 2, partial with respect to y. So let's find the derivative of this with respect to y. So differentiate 3 with respect to y. So we get fy equals, this is 0 with respect to y, 2y, so 2x squared y, and this is a single variable function, so partial derivative is same as regular derivative, so this is h prime y, equation 4. And then we compare 2 and 4. Our function, potential function f, is here in fact given by 3, provided we know h. And to find h, we compare 2 and 4 now. Looking at left hand side, is the same, 2x squared y, we have that. So h prime y equals, there is nothing, means plus 0. Okay, so comparing these two, we get h prime y is 0, integrate h of y equals some constant, okay, because derivative of constant is 0. In fact, we may take this constant 0 because we are finding a potential function, okay, or hy is just 0. Then plug this in 3, we get a potential function x plus x squared y squared, h of y is 0. Now we have the potential function. So let's go back. Now this line integral is same as, this will be same as potential function at the terminal point, that's 5 1 5 minus that potential function at 1 1. Okay, that's the case, and this is given by the fundamental theorem of line integral. So as soon as we find this little f, then this line integral is easy. Okay, so let me go down here. Then the line integral f dot dr, that is in fact the work done by this force moving on this curve from 1 1 to 5 1 5. So this is same as f at terminal point minus f at initial point, and go back and check, that's 5 1 over 5 and 1 1. Okay, and our function is here. Let's plug in x and y. So 5 for x, 1/5 for y. So 5 plus 5 is squared 25 times y squared 1 over 5 is squared 1 over 25, that's minus 1 1 1 plus 1 25 cancel, 5 plus 1 6 minus 2, so 4.